Let's begin. Today's October 30th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 7, 9, 12, 16, 21, and 22. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our last digit, the circle digit, and Turing Machining will let us know whether it's an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2, maybe even all 3 are 3. Criteria card C will take a look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D, again, we'll take a look at the 3-digit solution, but this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E, again, takes a look at the 3-digit solution, except this time it'll let us know a little bit about its structure, so to speak. Specifically, it can tell us whether there's a pair in the solution, as in the example 131, or alternatively, there are no pairs, but there are 2 scenarios. One where either all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F will take a look at our 3-digit solution from triangle to square to circle, and the Turing Machine will let us know whether the digits appear in an ascending order, meaning that they're increasing, as in the example 135. It can tell us that the 3-digit solution is in a descending order, or basically they're decreasing, as in the example 421, or alternatively, the 3-digit solution has no order. And let's take a look at the example 231. Notice that it goes from 2 to 3, it increases, but then it goes from 3 to 1 and decreases. Of course, it could also go first decreasing and then increasing, but ultimately it's that shift. That's one way to describe a 3-digit code as having no order. We've also seen in previous puzzles when you have consecutive equal digits, where that also exhibits no order. For example, let's take a look at 331. Notice that when it goes from 3 to 3, there's no change. It neither increases nor decreases. So again, consecutive equal digits are another way that a 3-digit code can exhibit no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card A. I'd like to know a little bit more about that circle digit. Okay, so the Turing Machine approves of my choice. I did pick an even 4. So the Turing Machine confirms that yes, circle is an even digit. So let's go ahead and type that up in our notes in section A. And again, we'll say that circle is an even digit. And of course, since it is even, let's go ahead and cross out all 3 odds. So crossing out 1, 3, and 5. So the next thing I think I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my choice of 314. Notice that in my proposal, I do have two odds to a single even. The fact that the Turing machine does not approve of that lets us know that, in fact, there should be more even than odds, not less. So let's go ahead and type that up in our notes in section D. And we'll just say that even should be greater, or basically there should be more even than odds. Now notice we already have circle as an even digit. That means that potentially square and triangle might also all be evens. That's a possibility. Or it could be that one or the other among triangle and square are even. We just don't know that yet. And I think as a last test for this round, I think I'd like to test criteria card E. Okay, so for criteria card E, it's letting us know a little bit about whether there's a pair or not. Notice that in my proposal, 314, they are all distinct, so no pairs. So, and the Turing machine confirms that. So let's go ahead and type that up in our notes in section E. And again, what we'll say is that the solution has no pairs. And what can we say about that? The fact that we know there's a majority of evens and that there are no pairs. So let's see. If there are no pairs, we could have a single digit repeated 3 times, or they're all different. I don't believe it can be a single digit, a single even repeated 3 times, because if that were the case, then that would automatically be no order, because there'd be no change from the same digit. So what I'm proposing, or what I'm kind of deducing, is that yes, in fact, they should all be different. And since we do have a majority of evens, I believe the solution is going to include a 2, a 4, and an odd. So again, because there are no pairs, I don't believe it can be a single even digit repeated 3 times, because that would automatically mean there would be no order, making this card irrelevant. And so therefore, they must all be different. And because we have a majority of evens, it has, and there are no duplicates, right? No pairs. The evens are not paired up. They have to be distinct. So we have 2, 4. And of course, that last digit must be an odd. Okay, well, that does it for this round. We have completed our 3 Turing tests. So now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card B, the number of 3s. We also did not test or compare triangle and circle. And of course, we didn't test the ordering criteria card F. So one thing I think we can say about criteria card B is that obviously there's either a single 3 or no 3 at all. Because again, you can't have 2 3s or even 3 3s. And if there is a 3, fantastic. Otherwise, it's going to be a 1 or a 5. And I think based on past puzzles, I believe if we have a criteria card like C and F, I think we can deduce that the solution should have no order. So let me explain. If I knew the solution was in an ascending order, meaning that they are increasing, we would automatically know that triangle should be less than triangle. Sorry, let me repeat that. We would know if it's an ascending that triangle should be less than circle, because that's what ascending means. It's increasing. So yeah, triangle would be smaller, and therefore making this card irrelevant, criteria card C. Alternatively, if it's descending, we would automatically know that triangle should be greater than circle. Again, making this card irrelevant. So I think it might be safe to say that we can deduce that the solution has no order. Okay, because again, if it were to have ascending or descending characteristics, we would know something about triangle and circle. Okay, so at least now we can say that our solution should have no order. And now we can say, based on what we learned in round 1, that yeah, one of triangle and square is odd and the other even. The other thing I would like to point out, and notice that there's no mention of square directly. So somehow that's going to force square to be, again, either the even quantity or the odd quantity. Okay, so what can we say? Let's see. What if there were no 3s? So if there were no 3s, we would know that we would have an odd of either 1 or 5, and let's see, could we figure out where that 1 or 5 would go? Should it be in triangle or square? So, kind of hard to see that. The other thing I'm thinking about is criteria card C. Perhaps triangle and circle are both the evens, and that's one way to order them, right? Or to choose among them. So what could that imply if triangle and circle are even? We know they got to be distinct. So we could have something like, if there is no order, something like 4, 5, 2. Or 4, 1, 2, and the like. But yeah, I think there would be too many of those cases. Because again, somehow that square digit has to be forced into something. And if there are no 3s, I just don't see how we could choose a 1 or a 5, especially if there is no order. So let's go ahead and I'm just gonna choose 2, 3, 4. I don't know, not sure, but let's go with that. Okay, so I think the biggest choice I made is that I am saying that there is a 3. So let's go ahead and test criteria card B. Okay, so it is true that there should be a single 3 in our solution. So let's go ahead and type that up, and we'll say that the solution has a single 3-digit. And because there's only one odd, let's go ahead and cross out all of the 1s and 5s from both triangle and square. Now we haven't quite established, why why did I do that? I know there should be no there should be no order. Yet I chose 2, 3, 4. Okay, just a bad mistake. Okay, well, hopefully it won't set us back too much. Okay, so next, let's go ahead. Well, we know it can't be equal, and so it's got to be one or the other. So let's go ahead and test criteria card C. Okay, so in comparing triangle and circle, it is also true that triangle should be less than circle. So let's, since my 2 is less than 4, and the Turing Machine agrees with that. So let's go ahead and type that up in our notes. And again, we'll say that triangle should be less than circle. Okay, well, that's good. But again, I don't believe 2, 3, 4 could be the correct answer. And let's see, so what can we cross out because of that? So, or perhaps maybe we should list out the potential solutions. So let's see, what can we do next? So I think triangle can't be a 4, because that would mean that 4 is either equal to or greater than circle. So yeah, I don't think it can be a 4. So that's not a 4. Let's see, what else? Can we then cross out what? So 4, triangle can't be 4. So I don't think circle, can circle not be a 2? Is that correct? Yeah, so if circle is a 2, there's nothing smaller for triangle to be. Okay. So that means that circle is a 4, which means that square cannot be a 4 because we can't have duplicates. Okay. And because technically there should be no order, that would mean that, yeah, of course, 2, 3, 4 is invalid. Again, that was a mistake on my part. But now that means that among triangle and square, again, triangle can't be 2, forcing square to be 3. It's got to be the other way around. So triangle cannot be the 2, and square cannot be the 3. Oops. Square cannot be the 3. And so it looks like the solution should be 3, 2, 4. So let's go ahead and type that up and review it. Okay. And so basically, let's see, is our last digit even? It is. It's 4. The solution has a single 3. Sure does. Is it true that the first digit is smaller than the last digit? Yeah, 3 is smaller than 4. That's correct. There are more evens, and there are no pairs. That's correct, and has no order. Well, it looks like that works out. And so let's actually review, or verify that 3, 2, 4 is our solution. So let's see. Okay, fantastic. Now, what about how we did versus the Turing Machine? Okay, so we did have 6 criteria cards in our puzzle, and we did only 5 tests. So that's always promising that we did beat the Turing machine. Now notice that in the first round we did ADE, with D being the only incorrect answer. And in the second round, all we needed to test was BC, since we did deduce F. So let's go ahead and type that up. And of course, we did ADE again in the first round, with D being the only incorrect. And then in the second round, we did BC, and they both were correct. Wow, so we beat the Turing machine by 1 question. And more than likely, it must have been that we deduced criteria card F outright. The only fortunate thing I'll say is that I was just very lucky that this error in choosing that proposal did not derail us. It's hard for me to say if that's always going to be the case. I hardly doubt that, in the sense that it wasn't a huge impediment. Luckily, I had already done enough work to, I guess, minimize the potential damage. But sometimes that happens. We make silly mistakes. We really don't think about it. I don't think about it, obviously, sometimes. But we were able to bounce back. And so that's just one of the good fortunes. But how did you solve? What criteria cards did you choose, and in what order? And did you notice anything interesting that you'd like to share? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.